Hi, this is Tag again. Today I want to talk a bit about epowers and epowering a card. Now here is two examples, both of them done with blade. In theory you can do the connection with wires as well, but I really wouldn't recommend that anymore. It's just not very effective. You get really high resistance between the epower and the GPU. So let's start off with this one. This is sort of the easier way to do it. This was a rush job during last Team Cup, so it's not gonna be perfect, but this is quite functional, and I was able to take the advantage goal on this card, no problem at all. So it's not holding me back, at least not by much, I think. Now we have a ground plane here in the front. This is a ground plane between epower and the capacitor ground on this card. So there was a row of capacitors here, and basically this is the ground side of this row of capacitors. Here I removed the solder mask, and then you have another copper plate under here. This is the output side of the chokes from the original VRM. Now I also removed the solder mask there, and then what I highly recommend you also do is use the ground from the low side MOSFET. Now this is kind of the sort of minimal viable way, I would say. I don't think this is very effective here. I have two wires and there's the copper plate. Rather thin copper plate, but the original ePower has like connectors for wires and doesn't have the full edge like the modern ePower has. Anyway, here it was kind of in a bad spot, so I didn't remove the solder mask completely to basically solder it to the whole ground plane, and that's actually what you should do, and that's the next one here. This is a much more recent ePower, and I don't think that's the reason why it is better. I think the reason is more that with this one, again, this 4850 was done during Team Cup, so I was kind of in a hurry with this one. This one was just done for fun and for hardware points. So what we got here is modern ePower with the VCC edge here, and basically that allows you to solder the copper plate along the whole length. And also the bottom is again the output of the chokes on the original VRM, completely ground up. You can't see it now, but I'm going to show you later how to basically grind the PCB of a card to get it ready for a proper ePower. And the second plate here, now this is not what I would necessarily recommend doing unless you're very confident in your solder joints. Now on this one, actually I attached this ground plane here. It's between, again, fat grounds, this time like full length of the card. It goes all the fat grounds from the V-core, from the memory, and then it also attaches to a bit of the ground plane of the 6-pin. So this takes all grounds with one copper plane basically. All of the solder mask removed, soldered right across it. Now this one I didn't pre-bend. I would recommend you pre-bend your copper like this front one here, but if you're using 0.5 millimeter copper like I do, you can get away with sort of just bending it in place if you have really good solder joints. Now, the reason I did this on this card is that I wanted it to be relatively flat of a profile, so you can in theory SLI these. Also, one more thing, memory, you're absolutely fine with using wires. I just used two relatively thick wires for each and just hooked up the memory section of the ePower that way. It's not that critical, the resistance here, because memory doesn't have that much power draw. Oh, another thing. You always want to have at least some capacitors close to like where the power planes enter the PCB. In this case there's a single polymer here, then there is, I think there is two SP caps down there, Those are for memory. Those are pause caps for memory. And then there are some MLCCs I put back here. This is just to be safe. It shouldn't really matter much, but having a little bit of bulk capacity on the output of the epower is always a good idea. Now this one sort of not there, but these are VCore and these down here are also VCore. So I just used part of the original caps here. Okay, now let's get to a card and sort of show you how to prepare the power plane for e-powering. Now this is a dead 8800 GTS. Dead because I don't really have any cards I want to actually e-power right now. So we're going to use this as a sort of mock-up card. And for e-powering it, you want something like this. You can also just scrape away the solder mask with a screwdriver and then sand it down with sandpaper. But this thing makes it so much easier, and it's like, I think, 20 bucks or something on AliExpress. This is just a tiny little micro grinder thingy. And with that, you can just grind away the solder mask very easily. Now this one has a cutting attachment here because they didn't deliver mine with like the proper grinding attachment, but you can grind with this as well, you will see. So let's quickly remove all the VRM components, so our FETs and our chokes and all the capacitors, MLCCs around here, and maybe these, I'm not sure, I'm probably going to leave the input filter and capacitors on here. So let's do that quickly. Probably going to fast forward this part, and then I'm just going to grind this and show you how it looks afterwards, and sort of show you how I would put the copper plate on here as an example. Now obviously I can't do like an e-power video for every card out there. I'm just going to show you how basically my thought process goes as with an example like this, and then I'm going to leave it up to you to figure out how you translate that to your specific VRM layout on the card you want to e-power. Okay, anyways, let's get this thing ready. Okay, so here we are. All the VRM parts are gone. Now, maybe if this is a working card, you might want to shield the input filtering caps. Even though, if you're going to fully e-power it, as in VCore and MEM, then you don't need to bother because it's not going to be hooked up. So I left on here the fan connector down here and these couple caps. Now, you can remove those as well. Those are just output filtering of the VRM. And this is the input choke for 12 volts, probably from the PCIe slot by its location, in case you want to basically put the epower closer to it. But this is just aesthetics mostly. You're not going to get so much closer here that you will have a significant decrease in resistance. Okay, now let's quickly wick up. Should turn on the soldering iron, wick up all the excess solder here. Now usually if you're wicking you should put good solder on there first, but for me this like pre-wicking for grinding is a sort of an exception here, because I don't really care if it's a perfectly nice job. You're just basically wicking away the solder, so you have to grind less. Some solder doesn't really hurt, and you definitely do not care if you damage the solder mask or anything while wicking, because it's all going to come off anyways. There we go, good enough. And now, if you had a proper grinding attachment, this would be as easy as like going at an angle, but we have to grind with the bottom of the cutting attachment. So let's go around this. Okay, so I'm halfway through this and I realized that it's probably going to be not very entertaining to watch me for like 10 minutes grinding this card, so I'm probably just going to cut all of that out. And well, this is basically the halfway update. You can already see some power planes getting pretty exposed here, and I'm probably just going to cut to all of the solder mask being gone. And then we can continue with some discussions about how you would want to epower something like this. Okay, so this is what it looks like after the grinding is done. Now let's give it its finish with either like a polishing attachment or some really fine sandpaper. I think this is 800 grit, so not really fine, but relatively fine. Actually, let's do both on this card and compare. Okay, so here we go. Bottom is sandpaper, top is polishing thing. I'm not sure if there's much of a difference. As you can see, it works either way. So let's continue with some points here. Now you can see, hopefully you can see, that there's small little wires in here. Now, first thing you want to do is measure all of these to make sure, like if they are weak or if they are ground or something else. So let's do that. Okay, so I got the multimeter. Now these three here are obviously connected to VCore because you can actually see it if you look, but I don't think it shows on camera. So here you see this is roughly a short on this multimeter, and if I measure this wire here, it's also. So the more critical ones would be the ones here around this switch node. So this is one of the switch nodes, so all of the FETs are attached to this plane. The plane itself shouldn't be attached to anything. It isn't. So let's check towards VCore. Doesn't look like it's connected to anything. Come on. Yep. Okay, this wire is just switch node, I guess. Maybe. Yeah, it's connected to the switch node in some way. Probably disappears if we remove the drivers of the VRM. I wouldn't worry too much about that one. Or that one. I think that's ground. Yeah, that's ground. Okay, so the back one here is ground. You can see 0.9 ohms to VCore, 0.4 to ground. So we can also just attach a copper plate across this one if you want. Now we can obviously attach a copper plate across these little tabs that come up here, because those are just the gates of the FETs on here, and those are not going to be connected to anything once we remove the drivers. So drivers I'm talking about are those little, where are they? Here, here and here, those little rectangles here, or squares rather. And I would recommend removing those just to be safe, you don't short anything. I also often remove the controller itself to prevent any issues with it sending basically a not power good signal and pulling down the enable pin or something like the VMEM controller. Anyways, let's continue with the wires. Another one here. 3.7. Nothing. Cool. This one looks like ground again. Yep, ground. I think it's just a switch node again. No. Okay, so this back one here, I'm not quite sure what that is, so we're probably not going to attach copper plane over this one. Wouldn't have done it anyways, because you can see a little piece of the 12 volt plane here. This back here is 12 volts, and I don't want to get anywhere near that, even if we remove the input chokes. Still no point in really using that for anything. Now let's check this one. No. No. Yeah, again something like this. There is, I think, one here. No, that's just a grinding mark. Okay, there is some more up here. Looks like ground to me. Yep, that's ground. Okay, so we don't have any wires in the way of our power plane. Ground plane, I mean. So now what I would usually do is, let me grab a piece of copper plate. Actually this sort of works as an example. It's not quite long enough, but okay. Now, you can obviously see that there is like a little finger of V-core here and a finger of V-core right here. So there are two ways of dealing with this. One would be to put the bottom copper plate like here and the top copper plate over here. Another would be to just Kapton tape over the finger. So you want to just basically put a bit of Kapton tape over here. Now, don't really put it too tight, just leave it overlapping the other power planes a bit. And then cut off the ends. There we go. And now you can just attach one solid copper plate behind the V-core finger. So something like this. Now, for V-core itself, it would be really easy with this one. Again, let's use this as an example. Actually, this would fit pretty nicely. Just make sure you don't touch any of these edges of the ground here. Actually, you might want to grind a bit more here, or just use something with a relatively short lip like this one. So like this. And that's basically how you would prepare the VRM area. Now, for the copper plate itself, a little tip here. Obviously pre-tin them, and when you attach them to the card, use a little bit of flux between them. So pre-tin the card. Actually, let's just pre-tin it on here and show you what I mean. And then, another important point, copper plate corrodes over time. So you want to use some fine sandpaper to roughen up the edges you are soldering. You can see, gets nice and shiny. There we go. One side is sanded. Let's use this as a demonstration. Now, if I try to solder something to this side, obviously going to take some time to warm up, but it should start flowing relatively easily. See? Pre-tinned pretty well. Let's flip it around. This side I didn't sand. Let's see how much more effort it takes. Now, keep in mind this is already hot now, so it should even work on non-corroded ones. But as you can see, I'm scrubbing away at it, and even, come on, even after scrubbing it around, it's not going to look as nice as on the pre-sanded bit. So that's one thing to keep in mind. Just quickly pre-sand your copper plate. Okay, now for pre-tinning the board, same story. But here we already have it sanded. Let's clean this off a bit. Okay. Now this is going to take some time. Actually, this one doesn't seem to have high thermal mass, but usually it sticks the soldering iron straight to the board. because high conductivity and very, very thick power planes soaks up all the heat from the soldering iron. There we are. That's a nicely pre-tinned piece of power plate. Now let's check for shorts. This is V-core, this is ground. You should probably be able to see the multimeter. 1 ohm, 0.9 ohm. Just to make sure, measure between these two, 0.6 ohm. This multimeter has a bit of a loose jack here. But you can clearly see 1 ohm, 0.6, 0.5. So we didn't create a short pre-tinning here. And for the other side, again, I'm probably going to use 2 pieces, would use 2 pieces here. So pre-tin above your Kapton tape here, in case you use 1 piece. In case you use 2, obviously remove the Kapton tape. But that's again just an illustration to show how you would do it. Now, I really like using the switch nodes to attach ground to. So basically short the switch nodes to ground, because once you have all the FETs gone, the switch nodes are not connected to anything. But they are nice big pieces of exposed copper plane. So let's continue with that. Down here. Obviously avoid this little V-core finger. And you see the ground here is really good. My soldering iron is set to the maximum temperature and it sticks to the PCB. Damn, that's good ground. Yeah. Or my. That's really good ground. So go around here, and there is another ground down here. Perfect. Okay. So once you have pre-tinned your board and your piece of copper plate, you want to attach it. Now I use hot air for this. Hot air and the soldering iron. The other alternative is obviously just use one super powerful soldering iron that can easily melt the solder, even though you have massive ground connectors and copper plate here. Now, if you use hot air like I do, you want to cover your memory chips that are next to the VRM with Kapton tape. Now, I'm not going to do this on this dead card here, mostly because I'm relatively short on Kapton tape, again, and don't want to waste it on a demonstration project like this. So also, if you have a hot air, you want something that sort of clamps your hot air in place. Doesn't need to be perfect, just needs to be sort of resting around the area where you have your nozzle here. I like to stack something underneath it, like this. So it keeps basically blasting your copper plate. There we go. It's going to be a bit awkward. Now, usually if I'm doing this, I'm obviously putting the card in a position where I can easily work on it, but for this video I'm obviously going to put it in a position where you can hopefully see everything. So, once you have your hot air blasting the plate and the area, you want to fix your plate down like this. Just a little bit of flux. Then go along plate. Like that. Okay, it's on there, but I don't think it's quite strong enough. So let's add some more solder. Also, don't set the hot air to the hottest setting, obviously. This is just to sort of preheat our plate and the general area. Okay, now we got plenty of solder on there. Let's get the hot air away. Get our spacers away. Okay, so now we have the plate attached. I would say it looks reasonably clean. And let's just quickly check for short. Now it reads 0.6, that doesn't mean a whole lot. Our GPU is hot, so let's see what it reads. If we're both on the same pad, it reads 0.5, 0.4. So I would say this is normal resistance for a GPU that is, well, I can touch it, but it's rather hot. So we didn't short anything. Our little Kapton tape shield here worked. And another way of showing you that this soldering connection is good is to just try and basically bend the plate, and you're going to see that it doesn't rip. You can see at the back, under there. Now, if you put this plate straight on here, I would also give it another pass at the back, just to create more like connection of solder between the copper plate and the PCB. Just decrease resistance a bit more. Anyway, that's how you attach the plate to the GPU, or at least how I do it. So yeah, I think that's about it for the demonstration video. Now, I really wish I could show you a complete process of me epowering a GPU. But as I said in the beginning, I unfortunately don't have any GPU right now that I want to epower. Also, I don't have 3 epowers. I just have 2 attached to GPUs and a whole bunch attached to various motherboards. And currently I don't want to take any of them off of their like host piece of hardware to epower something for a video that I'm not going to bench. So yeah, that's it for the epower video. I hope it was helpful, and maybe you're going to give it a try yourself. Bye.